The contents of my presentation: introduction, numerical modeling, computational domain and mesh configuration, experimental setup, construction of the model, description of test conditions, numerical calculations, experimental results, and conclusion. Firstly, we talking about ship resistance characteristics calculated using various methods, just some of them from CFD numerical calculations and the others from model testing in Tongue Tank. For CFD validation of resistance and propulsion, we use benchmark database which available for us. Some of them talking about Series 60 MPL, maybe DTMB. All the benchmark experimental data used to validate the CFD results and gathered using the same hull model. This paper used to determine an accurate numerical prediction of hull model resistance, sinkage, and trim flow field surrounding the hull model at various fruit number scenarios. CFD results as a primary step of production of validated ship model, then compared with experimental investigation and Tongue Tank for model verification. So our paper compares the experimental results in MTCTT Military Technical College Tongue Tank with already documented results on DTMB 3-meter benchmark to ensure adequacy of laboratory setup and procedures. Results of the extensive experimental are presented, forming a benchmark for numerical methods validation. Now we're talking about numerical modeling. The body plan of DTMB model, one of the best choices to simulate turbulence flow around ship hull. We used it to validate a new numerical method on this combatant hull. In this paper, we used combatant ship model corresponding to scale 51.1 used for CFD calculations. You can see the body plan and all the lines of the DTMB with length 2.78 meters. In this slide, we can show the computational domain and the mesh configuration. This is domain, its length 5 overall length of DTMB, and the breadth it's the same length of DTMB, and this is 2 partitions, subdivisions, air and water. For meshing, we can use structured and unstructured mesh around 1.15 million cells, the computational domain using hexagonal components. We use 3 meshes, coarse, medium, and fine, with total elements count 1.15, 1.32, 1.45 million for coarse, medium, and fine grade. The calculations here use SST K omega turbulence models. After using or finishing the numerical calculations, we use the experimental setup. First, we talk about military technical Tongue Tank in Cairo, Egypt. This Tongue Tank is 45 meter long, 5 meter wide, and water depth 30.8. With technical specifications, we include jet frame carriage with speed 2 meters per second, carriage maximum payload 50 kilogram. It equipped with a complete wavemaker system that includes 8 multi-flap paddles. This Tongue Tank, designed and built by Edinburgh Design. Then we talk about construction of the model. The length between perpendiculars 5.72 meters. this model, this is the first model. Uh, Shift model tests on constructed in the model factory Edinburgh design, and the MTTC model is constructed from fiberglass. We can see the model here, slide 13, and this is bulk here. Resistance measurements are made from foot number 0.05 to zero point 0.4, as well as sinkage and trim. Here we can see the curve for temperature and the dynamic viscosity. So the first step for experimental work, we use DTMB number 541551 model calm motor resistance, testing CFD against model speeds from 0.25 to 2.3 meter per second, flow number 0.05 to 0.45, with three different mesh sizes. And this curve illustrates that the calculations of coarse, medium, fine, with maxor. And these numerical calculations for resistance coefficients for experimental results. The total resistance experiment data for our model with this for total resistance with speed. Maximum speed for the surge is 2 meters per second, so the maximum here is 2 meters per second in this curve. We repeat some of calculations, some of experiments, maybe 10 times for specific velocities or speeds at 0.5, at 1, at 1.5, at 2 meters per second. We repeat this experience for 10 times and use Prohaska test to calculate 1 plus k. And these calculations for sinkage and trim. This chart, time resistance chart, time velocity chart at 2 meters per second, two charts. And we can see the wave pattern along the hull using the cameras used in towing tank and the wave contours along the hull at fruit number 0.3. Our conclusion, significant portion of the current data set was cross-validated using experimental results obtained at DTMB, yielding a very good result. Extensive comparisons between our CFD calculation and experimental results for DTMB show that the method used is acceptable and that the mesh generation method can be used to estimate the model's hydrodynamic performance. Fine grid will be utilized since it's most appropriate for the calculation and produces the best results because convergent results are achieved as mesh size decreases. According to the comparison of total resistance grid results by CFD, on the other hand, the obtained experimental results validated the setup of the towing tank facilities and adequacy of the procedure. Thank you.